Good evening, everyone. So we'll just wait for another 5 more minutes, and we'll be starting the session. And the people who have joined, welcome. So yeah, good evening everyone. So without any delay, we'll be starting the session now. I hope all of your friends have joined this session. Okay. So I welcome everyone to Artificial Intelligence and Machine Learning this course. Okay, and myself is Shiva Chiran. And in the meantime, whatever the doubts that you're having now, please all the doubts will be cleared at the end of the session. Okay. At the end of the session. And before that, a quiz will be kept, and after followed by the quiz, there will be a Q&A session for last 10 to 15 minutes. Okay. So what are the doubts you're having? Please note down all the doubts. And when the window is open for Q&A, please post your doubts over there. Okay. So yeah, let me just walk you through this. So machine learning, artificial intelligence, generative AI, AI agents, agentic AI, these are all the terms which we are hearing in today's current world, correct? But before this generative AI or deep learning, machine learning is the term which came to the picture, okay? It actually helped to predict things, forecasting things what could be the price prediction for any particular category or the sectors. It helped the people in many ways. Okay, you can see over here clearly, it helps us to automate the task, like and also in a way where it helped us to drive smarter decisions and the innovations across industry. So I'll just walk you through the introduction slides. Okay, so basically the major thing, what is AI and what is machine learning? I hope everyone is able to see the screen clearly now. Okay. So as we can clearly see over here, artificial intelligence and machine learning, both of the single line overview definitions are over here, where it is actually saying about carrying out tasks in a way we consider is intelligent, and where the system learning and improving from the experience. Okay. And this line is very important. When we program many things now, let's say in our day-to-day life, we'll be using many different programming languages. We'll be experimenting with many different set of code lines, correct? So those set of code lines the explicit are explicitly programmed by us, correct? But without even programming, how a particular algorithm or how a particular model is able to do the things in its own way, that particular thing comes under machine learning. Okay, so where the system will be learning and improving from the experiences itself, and there is no need of programming explicitly to make sure that the model actually learns those patterns. Okay, the model will be learning those patterns and improving from the experiences. So experiences in the sense, coming into machine learning, we are having many different learning techniques. Okay, be it supervised. Like these are the three different learning techniques we are having in machine learning. The main three things are supervised learning, unsupervised learning, and reinforcement learning. Each kind of learning will be having their own method of learning. Based on the types of the data which we are having, each of the learning will be varied. Okay, and moving further, I'll be explaining what exactly supervised, unsupervised, and reinforcement learning is. And before that, we'll just see how AI or else machine learning are used in a day-to-day life. So these are the three different scenario examples that which you are seeing. Even I will provide a few of the real-time scenario examples. So initially product recommendation system. So let's say if you people are browsing Amazon or else Flipkart or else Myntra or else any other e-commerce application. So initially you'll be searching for the item that you are looking out for, or else that you're out like if you're curious about any particular product, you'll be going out over there and you'll be checking out the price and the reviews of that particular product, right? But if you just scroll up a little bit, you'll be getting a similar products, correct? You'll be getting a similar products as a recommendation. And how such kind of products are being recommended to you, and that works through machine learning itself. Okay, that works through machine learning itself. So in a similar way, fraud detection also. See, even this one is actually very good. Banks and financial institutions use AI to instantly spot fraudulent transactions, protecting your money from theft. So this particular thing, how it will be doing it? See, like let's say if a person approaches you and he will be asking for the specific, he'll be asking for a specific amount, and how will you be able to estimate that particular person will be able to repay that particular amount to you? Not directly estimate things, right? But how a model is estimating those things, a model is able to identify the fraud detection, how a model is identify the person who will be able to repay the loan, or else uh, who will be under the category fraud, who will be not under the category fraud. There were like few parameters, okay? There were like few parameters. Based on those few parameters, the bank will be deciding, right? Based on his education, based on his family background, based on the assets he's having. So by considering all these parameters, then the model which we are having, it will be learning the patterns and the relationship between each and every parameters which we are having. Then it will be saying exactly if that person is gonna fraud us, like if that person is falling under fraud category, or else if that person is genuinely seeking out for a loan. And moving into personal assistance, like nowadays you're saying Siri and also Alexa, Google, correct. And another example that you can consider is, see guys, this example is for deep learning, but I think everyone will be relating to this particular example. Example is like whenever you're texting your friend, okay, whenever you're texting your friend through your phone, let's say people are planning out for a film, okay, let's say people are planning out for a film, and so you randomly had the thought in your mind and you're texting your friend like, let's go to film tomorrow. So even before typing tomorrow or else film, you'll be seeing the predictions over there on the keyboard, right? That even that thing is happening through an algorithm itself. Everything that we are seeing in our day-to-day life through our mobile phone is happening through either machine learning algorithm or else through LLM itself. Okay, so I'll just move forward over here. I hope everyone understood like how in our day-to-day life, without even knowing, we are using these machine learning or else LLM application, like LLM models. Move forward over here. Yeah. And some more examples you can consider over here. Yeah, self-driving cars too. You all know one of the major example we can consider is Tesla cars. Correct. And medical diagnosis. Nowadays, I don't know if you people have heard this news. There was a news that even before having these cancers, right? Like few other people will be affected with the cancers, right? Like stage 1, stage 2, stage 3, and stage 4 cancers. So nowadays, based on the X-ray report itself, we'll be able to identify if that person is having any disease or not, or else if that particular person is in his early stage of cancer or not, based on the behavior and that, based on the medical report patterns. So that we are able to achieve through this machine learning algorithms itself. So I think you people have seen a few people uploading X-ray reports directly and getting an analysis, full analysis report. How it is happening? It is happening through algorithms itself, through deep learning algorithms. Even there was an event happened in China like a few months back where there were like three different doctors were sitting over there, and one AI bot was sitting over there, and at a time both were analyzing the same reports. Hope you people have heard this news. So the AI was analyzing it more accurately and with much more precision when compared with the doctors over there. So that is one way how AI is being fast forwarded in nowadays day-to-day life. And the predictive analytics. Predictive analytics, like how previously we have seen one of the fraud detection example, right? So that you can consider like identifying the patterns, data to make predictions about the future events, trends, and behaviors. Just like today evening, it is going to be rainy, or else tomorrow morning it is going to be rainy, or else tomorrow afternoon it's going to be sunny. Such kind of predictions, or else finding out the pattern based on the temperature, based on the humidity. So those such factors come under, such kind of domain or else such kind of things come under predictive analytics. And personalized experiences too. Just now we have discussed about recommendations, content recommendation. Yeah, content recommendation or else tailoring the content also. The best example you can consider over here is Netflix. Let's say if you search for a category, then you'll be getting a similar kind of recommendations. Like let's say I'm searching for horror, so I'll be getting a similar kind of movies related to that particular plot also. Correct. So these are some of the machine learning examples which we'll be experiencing in our day-to-day life, but we won't be noticing much. But please start noticing these guys. Things will turn interesting. I'll just walk you through those previous examples once again. So product recommendations is one thing, fraud detection, personal assistance, self-driving cars, medical diagnosis, predictive analytics, personalized experiences. So these are some of the examples which we are not noticing in our day-to-day life, but these are actually happening. Okay, fine. I'll just move to next slide. Okay, this is very important actually. So from here, the actual thing starts. I mean, we have been in the session from the very start itself. I have mentioned this supervised learning, unsupervised learning, and reinforcement learning. So what is this supervised learning? I'll just walk you through this line and then I'll be explaining it, okay? So the algorithm learns to map inputs to output by being trained on a labeled dataset. Okay, so initially to understand what exactly is supervised learning, we need to understand what is a labeled dataset. Okay, what is labeled dataset? So labeled dataset means here, I'll just give an example. So I just want to do the weather prediction. We'll just consider the weather prediction, okay? So now I'm having all the temperature parameters, all the previous temperature parameters, humidity parameters. And now I just want to predict what will be the temperature for the next 2 days, or else I just want to predict how the temperature will be for the next 1 or 2 hours. So here, initially, I'll be looking through my dataset once. And I'll just make sure that I'm having all the required parameters of the columns. I'll be doing a prediction. So in short, label dataset is nothing but where we'll be having rows and columns in an organized format, okay? Rows and columns in an organized format. Label dataset is. And what about the algorithm learns to map inputs to output by being trained on? So here, label dataset means now one thing is clear for us, that where we'll be having the data in the format of rows and columns in an organized format, correct? So that particular data, we'll be considering that, we'll be reading the data, and then we'll be pre-processing the data if there is any such irrelevant columns or else irrelevant like duplicate values, null values, such kind of things we'll be eliminating, and then we'll be getting the proper clean data set. On that particular data set, we will be making sure that we are dividing that data set and we are passing that to the model, and the model is learning the patterns. Model is nothing but the machine learning algorithms, okay? That algorithm is learning patterns. That algorithm is learning patterns, and then is it predicting properly or not? This is what the format which we'll be checking. Okay, just a moment, guys. Okay, I'm sorry. So label dataset. So two things to remember over here in supervised learning, where we'll be having a labeled dataset. Labeled dataset in the sense the dataset with rows and columns. I mean, yeah, with rows and columns in an organized format. Dataset again. What is dataset? Dataset is nothing but again in an organized format, in a tabular format, we'll be having the data. Okay. So on that kind of data, we'll be passing that data to our machine learning algorithms, and our algorithms will be predicting the things. Okay. And here unsupervised learning. The next type of learning is unsupervised learning. What is unsupervised learning? What it is saying exactly, the algorithm discovers patterns and relationships in unlabeled data without any specific goal or target. Understand the difference? Here, in the supervised learning, we'll be having a labeled data set, and in the unsupervised learning, we'll be having an unlabeled data set without any specific goal or target. Okay, these are the things to remember. Okay, just a moment. Okay, so labeled data set, and here we'll be having a specific goal or a target in supervised learning. But coming into unsupervised learning, now we'll be not having a specific goal or a target, and we'll be having an unlabeled data set. Okay, what is this specific goal or target, and what exactly is unlabeled data set now? So label to, like we all know what exactly is labeled data set. And coming to unlabeled data set now, unlabeled data set is nothing but even here the data will be present in rows and columns itself, but we'll be not having any specific targeted column over there. Okay, in supervised learning, we'll be having a specific target column, but in unsupervised learning, we'll be not having any specific targeted column. So for that reason, we'll be calling that particular data as an unlabeled data. Okay. Let's say, for example, one of the example which we have considered for supervised learning is what? We have considered one temperature prediction, right? Yeah. So we are having a specific goal or target. What could be the temperature for next hour or else next day? But in unsupervised learning, there will be no specific goal or target. So one of the example you can consider, one of the unlabeled data example that you can consider over here is cars. Okay. Let's say a person is working in a particular office, I mean, in a particular company, and there is this HR representative who is monitoring all the employees' absenteeism at the work. Okay, how many employees are being absent? How many employees are being late? How many employees are being traveling from the very long distances? How many employees have kept leaves in this particular month? And what is the pattern of that employee? Is he keeping leaves on Mondays and Fridays? So such kind of data set we'll be calling it as unlabeled data set, where we are not having any specific goal or target. We are just trying to find the underlying patterns and the underlying relationships between each and every column. Okay. So that is one of the best example you can consider for unsupervised learning. And moving into reinforcement learning. Reinforcement learning, just a moment. Yeah. So moving into reinforcement learning. What is this? Reinforcement learning. Okay, the name itself is saying. And what exactly it is? Algorithm learns by taking actions in an environment and receiving rewards or penalties to maximize a specific outcome. That's it. I mean, it may sound a bit typical, but the thing is, here the algorithm will be learning based on the actions. So the reinforcement learning is nothing but it works purely based on the reward based system. Okay, reward based system. So one of the best example that you can consider for this reinforcement learning is like I hope everyone uses ChatGPT in their day-to-day activity. So whenever you ask ChatGPT any query, yeah, the ChatGPT any query. So sometimes what happens now, it will, like let's say you have uploaded a document and you have asked it to summarize that particular document, okay? And it has summarized that particular document. And again, you need some changes. So you have mentioned, you have mentioned in the prompt once again to make the changes. Now, in the second attempt, now it is giving two different responses. Two different responses. Like you will be noticing response one and response two, and it will be asking you which response will you be referring to. Correct. I hope you have came across this particular thing. So if you select response one as the option that you prefer to, then if you observe, there is a similar kind of responses which will be coming up. Let's say response 1 is up to 5 lines, response 2 is up to 10 lines. You select response 1 now, all the followed by questions outcome will be under 5 lines itself, or else up to 5 lines itself. So what exactly is happening over there? So based on the input which is being provided by the user, it is awarding that particular response 1 and it is punishing response 2. So punishing response 2 in the sense, next time it will just make sure that it is not answering the format of response 2. It is answering only in the format of response 1. I hope you people have observed this response 1 and response 2. Okay, so such kind of learning comes under the reinforcement learning. Okay. So this is about, this is an overview of supervised learning, unsupervised learning, reinforcement learning. I'll just walk you through supervised, unsupervised, and reinforcement once again. The major things to remember in supervised learning is we'll be having our own data set, and that data set will be in a labeled format, and we'll be having a specific goal or a target in supervised learning. In unsupervised learning, here the algorithm will be discovering the patterns and the relationships, okay? Unlabeled data, where it will not have any specific goal or any target. And moving on to reinforcement learning. So this algorithm will be learning based on the actions, in the sense reward and punishment based system, where it will be rewarding based on the action. We'll be giving an input to consider that action under a reward or else a penalty, and based on maximum votes to reward or penalty, it will be acting accordingly. Okay. So this is a major difference between supervised, unsupervised, and reinforcement learning. And these are the types of learnings in machine learning. Let's move forward over here. Yeah. Again, we can see the key differences over here. Supervised requires labeled training data on predicting known outcomes, like mainly focuses on predicting known outcomes. And unsupervised learning, it discovers the hidden patterns in unlabeled data and identifies the instincts, structures, and relationships. And reinforcement learning, it will be learning by trial and error interactions. That particular term is very important, okay? Trial and error. With an environment maximizes a reward signal. Just go through these key differences for a minute, guys. Everyone, please go through the. Okay, so now I hope things are clear. Okay, fine. I see reactions. Thank you. Yeah. Terminologies. Terminologies is very, very, very important. Okay. These things. Algorithms, model, training data, testing data. I'll just walk you through these terminologies now. Don't worry, I'll be explaining each and every terminology, okay? So, firstly, algorithms. What is this algorithms? What it is saying? Step-by-step procedures for calculations and decision-making process. Decision-making process in the sense, what exactly happens in supervised learning and unsupervised learning? We all know that we'll be having some machine learning algorithms, and that machine learning algorithms will be taking our data as an input and it will be doing predictions, right? So that particular process, like whatever that whole process or is that algorithm which we are considering, that is what exactly the algorithm is, okay? Which will be considering the things and it will be going through step-by-step procedure of the calculations, make a proper decision. And moving on to, okay, fine. I see reactions. And moving into model. Model is nothing but a mathematical representation of real world process used in predicting outcomes. So this thing, training data and testing data, these are very important. Okay. Let's say if a person approaches you and if he mentions that I have worked on machine learning, then these are the major basic terminologies. Okay, algorithms, models, training data, testing data. So what is this training data and testing data? So let's consider any learning. Okay, for now, I mean, you people can consider any learning, but for now, I'm just considering as an example of supervised learning. Okay. So in supervised learning, what I'll be doing exactly in supervised learning, I'll be having the data set, right? So from that data set, initially I'll be going through all the pre-processing steps. Then here I'll be considering any one of the machine learning algorithm, depending on the type of the problem I'm having. Okay, depending upon the type of the problem I'm having. So type of the problem in the sense here it comes into classification and regression. Okay, we'll discuss about them. Don't worry. Classification and regression are the two types of the problems that we'll be working on in supervised learning. Okay, so depending upon the problem, we'll be considering any one of the algorithm, and from here we will be dividing our data into two segments. Two segments in the sense, two different kinds of data we will be having, training data and testing data. So what exactly is training data? What exactly is testing data? Like in one simple line, if you want to define it, training data is nothing but the model will be or the algorithm will be training on these particular data, on that particular data which is present under, which is being tagged as the training data. It will be learning the underlying patterns. It will be learning the relationship between each and every column models, each and every parameter, and then it will be giving us the decision. Okay, it will be going through each and every step-by-step procedure and calculations, and the decision will be made. Okay, and to make the decision, we are having algorithms, but algorithm needs to be fed with the data, right? You getting? So initially, to build an algorithm or else to build a model, exactly to build a machine learning model which is able to predict things on our data which we are having, we need to feed our data into that particular algorithm. So in order to feed and after feeding the data, the model will be learning, right? So that particular data which will be assigning to learn, I mean, assigning for the model to learn is known as training data. Okay, so I'll just mention things now. Let's say I'm having 100 rows. Okay, let's say I'm having 100 rows in my data set. So 70% of the data I can consider for training. Okay, 70%. And remaining 30% I can consider for testing. 70% for training and 30% for testing. Why testing is required? Because we need to know actually if our model is predicting things properly or not. So that is the reason we'll be giving a major set of percentage, like major set of information to our training data and the minor set to our testing data. Or else we can divide it into 75 and 25 also. It depends upon our dataset shape, okay? Dataset shape or else dataset size. So that is what the training data and testing data is, okay? Testing data is just to check the model performance. Training data is to train our algorithm, okay? Train our model. Okay. So these life cycle steps are very important now. Life cycle steps. So data collection, first and foremost thing, data collection. So now everyone, just if you are carrying any note along with you, please keep those notebooks or pens aside and just think, okay, what are the things which I'm saying right now? Even you people think along with me because even you will be involved. Consider this as a kind of an activity right now. So everyone, please choose your own domain. Okay, let's say I just want to think about the food related domain, and here I just want to mention things about ice cream. Okay, I want to do ice cream. So what is the thing that we are doing over here? We are learning machine learning steps. Okay, machine learning process in 6 steps. Machine learning process, nothing but the life cycle of machine learning. Life cycle of machine learning. Let's say we are having our own data and how the data will be used and how we will be building a model on the data and how that model will be able to predict the things. So that is what whole machine learning life cycle is. So initially, in order to build any algorithm, we need to have data, right? So data collection. Data collection is nothing but gathering the information from the sources which we are having. Okay. So let's say I'm considering the domain as ice cream over here. Okay. I'm considering the domain as ice cream over here. So I will be collecting all the information related to the ice cream brands and the ice cream flavors and also the ice cream parlor locations where we all the locations where we are having in the prime cities in the metropolitan areas like metropolitan cities like Chennai, Hyderabad, Mumbai. Okay, so I'll be collecting all this data. So data collection is the first and foremost important thing. Why? Without having the proper data, okay, without having our proper data, the model will not be able to learn any pattern over there. The quantity is not important over here, but the quality is very important over here when we are working on any machine learning model. Quality in the sense, let's say I'm having one row. For example, I have considered ice cream, right? So one row followed by few columns, like the columns are like brand, flavor, and location. Just consider. Okay, so one of the brand is Arun, and the flavor is chocolate, and the location is let's say the location is India, or else let's consider Hyderabad. Okay, and followed by the price of that particular ice cream. Okay, so this is the first row values. We are having Arun, and followed by the chocolate flavor, then followed by the Hyderabad location, followed by the price. So the same values are being repeated multiple times. Will that be helpful for us to predict different outcomes? Right. So we prefer quality over quantity over here. Okay. So the first and foremost thing, the much diverse the data is, the better the model works. Okay. With this. So data collection is the first and foremost important thing over here. And moving forward, data pre-processing, another important step. Data pre-processing. So what is this pre-processing? So just now, just give a thought for this data pre-processing, guys. Just give a thought. Okay, fine. So I think if you people are listening, I have just mentioned one line now. What was that? We prefer quality over quantity, right? If the same row is being repeated multiple times, the model will be learning on that particular value only. Most of the time, that model will be learning on that particular value multiple times. Correct. So in that case, what happens? The model will tend to give that kind of outcome only. So we need to make sure that such repeated values are being eliminated. We call them as duplicates. So in data pre-processing, we'll be eliminating duplicates, and null values also will be having null values in the sense sometimes for that particular column or else for that will be not having any values over there, and here null values will be representing it through NaN, not a number. We'll be saying it as NaN. So if anyone have seen any data set, they will be getting to know what exactly NaN means. Null values is nothing but actually there was a value over there, but that is a missing value. Okay. So such kind of missing values is being represented as NaN. Okay. So that is one thing. So and many things comes under data pre-processing. We have feature engineering also, and we'll be discussing them further. So this particular slide is talking about different segments present in data pre-processing. In data pre-processing, I mentioned duplicate removal of duplicate values, removal of null values, and also we have this parameter called as outlier. We'll be removing outliers also. So what exactly is an outlier? I'll give an example for this, okay? Outlier is nothing but the value which is being completely different from the other values. Just like, let's say there are a group of people who belong to one particular class. So most probably their age will be, let's say there are a group of people belong to third year bachelors, okay? So their age category will be under 19, 20, 21, 22, right? In this particular category only, there will be all the people will be present. Correct. All the ages will be in that particular category only. Let's say one person age is 28. So he is an outlier in that particular class. So we need to make sure that that kind of outliers are not affecting our model. Okay. I mean, it's fine if an elder person is listening to class, but we'll be identifying them as outliers. Okay. Just remember that for now. So that is another kind of data pre-processing step. Evaluation. Model evaluation in the sense we'll be evaluating our model. How we will be evaluating our model? Remember, I have mentioned two different types will be present: regression and classification. Based on that, we'll be evaluating our model. If it is a regression kind of a problem, there were separate evaluation metrics for regression like RMSE, R2. We are having those evaluation metrics, and if it is a classification problem, we'll be having different metrics like ever heard of classification confusion matrix, true false table? So through that, we'll be evaluating things. And after model evaluation, we'll be having deployment. Deployment in the sense we'll be deploying our model. When once our model is done and it is predicting well, then we'll be deploying our model. Okay. And after deploying, another important factor is monitoring. Is our model behaving same? Okay, monitoring is an important thing. And based on the monitoring only, we'll be deciding to consider that model or else we'll be moving forward with another model. So these are the 6 major life cycle steps. First one is data collection, data pre-processing, model training, model evaluation, deployment, monitoring. So just go through these machine learning process, guys. I mean, just go through these life cycle steps once. And yeah, just go through this for now for 2 minutes. Okay, so now we're done with the machine learning process, the life cycle steps. I'll walk you through the whole PPT once again, okay? And the future common application, these things. Before going into these particular slides, I'll just walk you through these things once again. Firstly, we had an intro, basic intro, then followed by the difference between artificial intelligence and machine learning. Then, what are all the day-to-day things that we are experiencing without knowing itself? Like product recommendations, fraud detection, personal assistance, self-driving cars, medical diagnosis, predictive analytics, personalized experiences. Then followed by the different types of learning, supervised, unsupervised, and reinforcement. Where supervised learning is nothing but it requires the labeled training data and focuses on predicting known outcomes. And unsupervised learning, it will be discovering the hidden patterns in unlabeled data, and it will identify the structures and the relationships. And in reinforcement, it will learn based on the trial and error method. And the terminologies like algorithms, model, training data, testing data. And then we have discussed about the machine learning process in 6 steps. 6 steps in the sense the life cycle of machine learning. This is data collection, data pre-processing, and data model evaluation, deployment, and monitoring. These are the major life cycle steps. So I hope everyone understood until here. And if you're having any doubts, do let me know. For now, okay. Fine. So I'll just stop my screen for now, and we'll have a short break. We'll have a short break for 10 minutes and be back, okay? Thank you. Okay, I hope everyone is back from their break. See many comments, many things mentioned in the Q&A. And the first major thing I want to address is into this Telegram link I'll be sharing at the end of the session. Okay, mostly we'll be ending the session early today, so by around 7:40, I'll be sharing the link. Okay, and the session is not yet done. This session is like from 6 to 8. Okay, in between we'll be having a short break, and at the end we'll be having the start of the end of the 10 minutes for Q&A. The regular queries that you'll be getting while going through the session. Okay, fine. Just give me a minute. I'll just share my screen. And here itself, I'll be sharing the Telegram link. Okay, don't worry. Okay, so we are done until machine learning process, correct? Like the machine learning life cycle steps. So moving forward, we are having a few more topics. We will be done with this particular introduction part. Okay, and coming over here, these are some of the common applications of AI/ML. Okay, natural language processing, computer vision, robotics. These are some of the common applications. Okay. So here, NLP or natural language processing is a very huge and very important concept, and so as the computer vision and robotics. Okay, just go through the definitions over here. Natural language processing, it will enable the machines to understand, interpret, and generate the human language. Okay, so whatever the text input that you are giving, it will be understanding that particular input, it will be interpreting that, it will be generating the output as per the input that you are giving. Just like how ChatGPT is working. ChatGPT works purely based on the natural language processing. What are the input that you are giving? It will be understanding that input, it will be interpreting that input, then it will be generating the output as per the input that you have given in a human language. Correct. So that is one kind of an application of machine learning. Okay, artificial intelligence or machine learning. Then followed by computer vision we are having. What is this computer vision? It will allow the machines to identify and process the digital images and videos. Nowadays, many people are able to what exactly like you understood. I hope you people understood what exactly is this. It will allow the machines to identify and process the digital images and the videos. Let's say the best example is Google Lens. Let's say if you point the camera to one of the famous personality, then what happens? It will immediately identify and it will tag the particular personality name. So that is one way where this machine learning or this artificial intelligence is helping us. Robotics. It combines both. Just a moment. So robotics, it will be combining both AI and machine learning to create an intelligent, autonomous, and adaptable robots. See, nowadays most of the factory workers are being replaced with robots. How? Let's say you people have. I hope everyone uses social media applications. So while going through your social feed, you'll be getting few reels related to some factory works, where all the fruits or the items over there will be running on the conveyor belt, and randomly the odd one will be picked out. How? It is happening through the combination of computer vision and robotics. Okay, so that is one of the common application. Okay, fine. And what could be the future of AI and ML? And I hope like nowadays people are even seeing it out over there. Everyone out over there is saying the future is AI, or the future is the days are gone. Actually, the days are gone. The future is machine learning. The future is data science. Those days are gone, guys. Now everyone will be saying that future is AI. But in order to learn AI, in order to understand how AI works, we need to know the machine learning. Machine learning is the base. Okay. Machine learning, deep learning, followed by all the transformer architecture models, DeFi models, diffusion models, followed by the whole cluster is known as generative AI. And after that generative AI, we'll be having AI agents, agentic AI. So we are currently in AI agents and agentic AI era. Okay. So, and we see at least for the next 5 to 10 years, there is a strong demand for AI rules, correct? And ethical considerations. This is very important, okay? Ethical considerations and human AI collaborations. What is the ethical consideration it is saying? It is saying that as AI becomes more advanced, there will be growing concern about privacy, bias, and responsible use of these technologies. That particular point is very important because let's say I'm having ChatGPT, I'm using ChatGPT. Okay. I just want to know, I just want to do a quick check on a bump which I got on my hand. Okay. Or the pimples which I'm having on my face. Okay. So I'll just click a selfie of my face, or else I'll just click a picture of my hand, and I'll be uploading it to ChatGPT, and I'll just give a proper simple prompt. Can you please analyze this? What exactly is happening over here, and what is this? And please suggest me a routine to make sure that this thing is gone. Correct. So then what happens? It will be suggesting things accordingly. Okay. But but is there any guarantee that those ChatGPT models is not being trained on your face, or else is not being trained on your hand? As per the company policies and as per the company regulations, they will be saying that they won't be using your images uploaded by the user. The images uploaded by the user. They will just mention that it will just process them and give the output. But the model will not train on that particular images of the input which is given by the user. But as the company is promising that, we are using it, right? Let's say if there is any new model which is in the market, if they're not promising all such things, will we be able to believe that particular model and are we ready to upload our things? No, right? So we need to. These are some of the growing concerns nowadays. Many new models are coming into market, but we can't make sure that in order to use that model, we need to make sure that the particular model published company is promising all these things. Okay, so that is the most important factor. And human AI collaboration. It's nothing but again, here we can see where AI will be working alongside the humans, augmenting our intelligence and capabilities rather than replacing us entirely. Okay, this one. Rather than replacing the humans, it will work along with humans. Best example we can consider is a chatbot for now. Okay, or the AI agents for now. AI agents. I don't know how many of you have gone through Comet. Comet is from Perplexity. Okay, Comet is agent where if I just mention my mail ID and if I logged into Comet through my mail ID itself, and if I just write it like this is a mail ID, just drop a mail to him saying so and so, then it will directly drop a mail to him through Comet. Okay, this thing is live and is happening. Just I need to mention the context over there. It will be drafting complete mail and it will be sending to him. I just need to mention the sender mail ID. That's it. This is where the future is heading. Okay, there were multi agents also into the picture. So in order to give a small idea of AI agents, nowadays we can see flight booking agent, hotel booking agent. What are they exactly? Or else travel plan itinerary agent. Let's say there is a website which is related to traveling or travel. Okay, and I just want to go to a nearby famous spot in my particular city. Okay, I'll be or else in a different city, and there is this tourist and also the tourist places available over there. So whatever the websites which are offering the tourist packages, nowadays they were using this AI agent also. Okay, and through AI agents we can directly schedule all the things. We can book our hotels. We can plan accordingly our pickup and drop point and check-in and check-out times in our hotels and the nearby famous spots and the nearby if there is a theater that we are planning to go for, we can go for that also. All these things will be scheduled and planned accordingly. Okay, so that is what AI agents are out over there. They just do the task. Okay. Okay, so moving further, this thing. Just a minute, I'll just know this. Okay, I'll just keep it over here. AI and machine learning in real world scenarios. So consider these domains, and drop a like you can mention the Q&A also. And how we are using in healthcare, how we are using machine learning or AI in our education sector, how we are using AI and machine learning in our finance sector, how we are using machine learning in our e-commerce, entertainment, and transport. How we are using AI and machine learning in all these different sectors. Okay, everyone, please don't use ChatGPT or just think and mention it in the Q&A. Okay, I'll be going through Q&A and I'll be reading it out once we are done with this. Okay. I'll just give 2 minutes of time. Okay, it's 7:23, 7:25. I'll be back again. I mean, back in the sense I'll be asking again.